All right, welcome back to another night of algebra. Tonight we're learning about equations with variables on both sides of my equal sign. Oh my goodness. All right, let's look at a situation that might require such an equation. The first thing we're going to do is get out our note-taking guide and turn to page 35 and follow along with me here. All right, see where example 1 is? Let's read this word problem. You can buy a skateboard for $60 from a friend and rent the safety equipment for $150 per hour. Or you can rent all items you would need for $5.50 per hour. How many hours must you use the skateboard to justify buying your friend's skateboard? Interesting. I've got two different scenarios going on here. On the one hand, I can buy a skateboard for $60 and rent the safety equipment for $150. Or I can rent all the items for $5.50. So let's look at this. If I buy it from my friend, that's this yellow area. And I would also still have to add the safety equipment, things like elbow pads, knee pads, and a helmet. And then I'm going to set that equal to my second option. And I'm going to see if it is equal, or at what point it ceases to be equal, or which side ends up bigger. The other option I had was to rent both the skateboard and all of the safety equipment. That was the part in blue. All right, so we need to find some variable to represent the number of hours that I have to own the skateboard. And that's ultimately my question here. How many hours? So let's let H equal the number of hours that I must skateboard. All right, and now let's come up with our equation. So looking at my equation here, I'm going to choose to let S represent the cost of the skateboard that I'm buying from my friend. And then I have to add it. See, it's a buy a skateboard for $60 from a friend and rent the safety equipment. So I'm going to let E be the cost of renting the safety equipment. Or I'm setting this equal to scenario number 2. Scenario number 2 is rent all the items you need. So I'm going to let that be R. All right, now let's look at what my numbers are. Back up here I said that my skateboard is $60. I got that here. I'm paying my friend $60 for a skateboard. And then renting the safety equipment, that E, is going to be $150 per hour. Okay, so let's think through this for a minute. $150 per hour. Is that saying $150 plus an hour? Is that $150 minus an hour? Is that $150 divided by an hour? Or is it $150 times hour? Well, I'm not adding an hour. I'm not subtracting time. I'm saying that I have to pay $1.50 for each hour. So that's going to be a multiplication scenario. My cost is going to only go up with time. That's why it is multiplication. Division would give me a smaller number. I'm expecting that I'm going to pay more as time goes up. So multiplication. So E equals 150 times the number of hours. And then I get my blue variable, the rental. To rent everything, including my skateboard, is $5.50 per hour. Again, this is a multiplication by hour because my cost is only going to go up as my hours go up. All right, so now I have some numbers. Let me plug these in. S equals 60. So I'm going to put 60 in place of S. And then E was 150 times hour. So I'm going to put that in place of E. Well, I don't even need my $sign. 150 times H for hour. equals my blue, which is 550 times h. All right, now I need to simplify and get all my h's on one side. Ruh-roh, what do I have here? I have h's on two sides. I have a variable on two sides of my equation. Oh my word. Well, I need to get all my h's on one side. So the one that I like to generally move is the one with the smallest coefficient. Remember, coefficient is simply any number that is multiplying a variable. So my coefficients here, my coefficients here are either 150 or 550. I like to choose the lowest number, and you'll see why here in a minute. So we're going to end up subtracting 150 from both sides. And it's not just 150, it's 150 times h, because it's kind of stuck to my variable so far. I can't separate it yet. So what I do to one side, I've got to do to the other. And let's see what I've got here. My 60's still kind of hanging out here. Make sure you bring that down and don't forget it. Now 150, this could also be written as this, guys. 150 minus 150. Oh, these are h's. Oh, don't do what I did and forget your variable. Equals, you could also write it out horizontally here. This is the exact same thing. So notice that my 150h minus 150h ends up canceling out. So I have finally just a constant on this one side, this number hanging out by itself. And then what is 5.5 minus 1.5? Notice that I have to combine like terms. They're both h's, so I can do some addition. This is the same thing as 550h plus a negative 1.50h. So 550 minus 150 hopefully will give you, all right, so I get 4.0h when I combine these like terms. And then I need to still get h by itself. So recognize that 4.0h is the same as 4 times h. When I have a number beside a variable, it's the same thing as multiplication between the number and the variable. So if I've got multiplication going on here, then I end up needing to divide. And I need to divide by the coefficient of h, which is this 4.0, or just 4. And I'm doing it to this side, so I also have to do it to this side. What I do to one side of my equal sign, I've got to also do to the other. So I end up with my 4's canceling out. I have h equals 60 divided by 4, and 60 divided by 4 is 15. Now, what does this 15h mean? Let's come back up and look at my variables and at my word problem. What I'm trying to figure out is at what point does it make sense to buy a skateboard from my friend and rent the equipment. And the time point at which it makes sense to borrow it is when the cost of owning a skateboard and renting the safety equipment ends up equaling the cost of renting everything. Because think about it this way. After 16 hours, if I buy the skateboard after 16 hours of skating, I now own the skateboard and I'm just paying for the equipment rental. Whereas if I skateboard for 16 hours and I pay for that rental, that ends up equaling, well, let's do the math. come back up here and look at, ooh, look at this part. This was the cost of renting. So at 16 hours of skateboarding, that's a lot of skateboarding, y'all. At 16 hours of skateboarding, it's going to cost how much to rent everything? Well, the rental was $550 times the number of hours. I got that up here. All right, so if it costs $550 times the number of hours to rent, then let's plug in the number of hours. I said that 15 hours was my break-even point. When at this point, owning and renting just the equipment equals the cost of renting everything. So what happens at 16 hours? The cost of renting everything becomes $550 times 16. If you end up doing that math, you're going to get $88. What is the cost at 16 hours of buying my friend's skateboard and paying for just the safety equipment? Well, remember that, I'm getting that equation from right back up here, guys. Remember that the cost of the skateboard was $60. So I'm going to plug that in to S. And the cost of my renting the safety equipment was $150 times the number of hours. And I'm getting that from up here. So let's see what this equals. 60 plus 150 an hour. I can't just add 60 to 150 yet. I got to do my multiplication here. And I'm going to plug this 16 hours in here. So I'm multiplying $1.50 times 16, and I get $24 plus $60. Remember, this 24 came from 150 times 16. And 60 plus 24 equals $84. So now looking at this, which one is cheaper? Is it cheaper to buy the skateboard and rent the equipment at 16 hours of skateboarding, or is it cheaper to rent everything? If you know you're going to be doing a ton of skateboarding and you're going to skateboard for more than 15 hours, according to this, it looks like it is cheaper to buy your friend's skateboard and rent the equipment, only if you're planning on skateboarding more than 15 hours. So just to recap, I created an equation where I have a variable on both sides. I had the situation where I had S on both sides, H on both sides of my equation. I had one here and I had one here. And it's because I had two scenarios that I'm looking to compare. I want to know at what time, H for time, these end up becoming equal, hence the equation. How long do I have to do something for it to become worthwhile? Let's look at another situation where you might need to do that. Let's look at this example from geometry. According to geometry, if I have two intersecting lines, then my inner angles or opposite angles are congruent, which means they're equal. So if I represent congruent angles with a single arc from one line segment to the other. Basically, it just means that this angle, whatever it is equal to this angle. So let's say that you know that this angle up here is 6x plus 3 degrees, however many degrees. It could be 40 degrees, could be 80 degrees, could be 92 degrees. And I know that this angle down here is 8x minus 21 degrees. Okay, I need to know exactly how many degrees this is. I know these two equal each other. How do I set this up? Well, hopefully you recognize that you could take the top angle, 6x plus 3, and you can set it equal to the bottom angle, 8x minus 21. If they're congruent, it means they're equal, so it means that each one of these is equal to the other. All right, now I have a problem though. I have x's on both sides of my equation. I need to get them on one side and get x by itself. Ruh-roh. All right, how can I do that? Well, let's move x. I can move x from one side to the other by either adding or subtracting or multiplying or dividing it. So let's see what we're doing here. And I always want to start with the smallest one. So which one's smaller, 6x or 8x? 6x is smaller. So am I adding 6x here, subtracting, multiplying, or dividing it with 3? Hopefully you saw that because it's positive over here, that I am adding 6x to 3. So I'm going to end up doing the opposite of addition, which is subtraction. And bring down your 3. Don't just leave that guy hanging out there. You got to remember him. All right. And what I do to one side over here, I've got to also do to the other. Ax minus 6x minus 21. Okay. So now this scenario is gone because 6 minus 6 is 0, which just leaves me 3. And now I've got this 8x minus 6x minus 21. All right, now let's combine like terms. What's 8x minus 6x? 8x minus 6x is going to give me 2x minus 21. I still don't have x by itself. All right, going back to what we did last night, I hope you remember that I have to deal with addition and subtraction before multiplication. So I am subtracting 21 on this side. So I'm going to do the opposite and add 21, and I'm going to do that to both sides. 21 plus 3 gives me 24. And now I'm just left with 2x, because negative 21 plus a positive 21 end up canceling out. Now 2x is the same as what? Multiplication. It's 2 times x. So the opposite of multiplication is division. I've got to divide this guy. What I do to one side of my equation, I've got to do to my other side. 24 divided by 2. All right, my 2's end up canceling out, and I get 24 divided by 2, which equals 12. And that is my x. Now, how do you check problems like this? Well, it's just like before. I end up having to plug it back in. So up here, I wanted to know what my angle was. So I'm going to have to take this 12, and I'm going to have to plug it in for x. So let's do that up here. I have 6x plus 3. That's this equation right here. I need to figure out what this angle is, how many degrees. And I'm going to plug my 12 from down here in for x. Remember that x equals 12, which we found down here. All right, so 6 times 12 plus 3. This becomes 72 plus 3, which is 75. So this angle is 75 degrees. Now, because we know they're congruent, then this one should also be 75 degrees. Let's just double check that. If I take 8x minus 21 and I plug 12 in for x, what do I end up getting? Well, 8 times 12 is 96, minus 21 is 75. That's so cool! And it all came from recognizing that these two equations are equal because the angles are equal. So I set them up using an equal sign. I moved x over so that I got all my x's on one side, and then I ended up getting x by itself, just like we've been doing before. All right, on your own now, I would like you to do the other two problems on page 35 on your note-taking guide. Page 35, it's the check understanding sections 1A and 1B. I want to see your work. For 1A, you should get -4/7, and for B, you should get 10. Please make sure to show me your work, include all of your steps, and I will check in with you guys later.